Intro Algebra Lesson 2-4A. Now that we've got a fairly strong grasp of adding and subtracting positive and negative numbers and what we can do with those, we're going to introduce the concept of grouping some numbers while we add and subtract them, known as a matrix. Now, a matrix is a rectangular arrangement, so it means they're going to be put together in such a way that they make rectangles, of numbers into horizontal rows. Horizontal rows go this way, and vertical columns, which go up and down. Inside the matrix itself, we would have what we call entries. Each number in the matrix is going to be considered an entry. We also can call them elements. Now, a matrix will look something like this, and it'll have these brackets, and the big brackets will have numbers inside them. So you could have 2, 3, 7, 0, -1, 4, let's say. And this would be considered a matrix that has a row right here and a row right here. And then these numbers create the vertical columns. Column, column. So rows and columns for each one. If this were the matrix that I had and I wanted to add it to another matrix, I could do so, as long as over here I had the exact same configuration. In other words, 0, -1, 7, 4, 4, -2. I have exactly the same number of rows, 2 rows, 2 rows, and 3 columns, 3 columns. If I have that, then I can add these together. If I don't, it won't work. If I do, like I have in this scenario, then this value is in the exact same location as this value, and I will add those two together. The 2 will add with the 0 and become 2. And then this 3 is in the same location as this -1, so they will add together to create 3 plus -1, which is 2. And you do that for each corresponding, which is the word for matching, corresponding location of this entire matrix. Alright, but if for some reason you did not have the same configuration, you had just 2, 4, 4, 0, then you cannot put these two together. It must have exactly the same number of columns and exactly the same number of rows in order for them to be able to add together. If they don't, we can't do it. We're basically stuck at that point. Now, you might find that you have the same numbers of columns and rows. So 1, 2, 3, or maybe I'm going to make that negative now, 4, 4, 0. But it's subtraction here. If it's subtraction, again, we can still make it addition. We just have to be willing to change the sign of every number that follows. And since there's no opposite of 0, it stays. So the negative became a positive, and all the other positives became negative. And then again, the corresponding places, you would add them together. So let's try some of these. Here we have a matrix with 6, 7, 8, 8, 5, 2 being added to 7, 1, 1, 2, 9, 0. And we want to come up with a new matrix that it equals. So we look at all the corresponding parts. And here you have 6 and 7 in the exact same location. So 6 plus 7 makes 13. And we have 7 and 1 in the exact same location. They add together to make 8. 8 and 1 are in the same location, add together to make 9. And then we have 8 and 2, which add together to make 10. And we have 5 and 9, which add together to make 14. And 2 and 0 add together to make 2. So since they have the exact same number of rows and columns, I can add the corresponding matching parts together, and I get a final answer. Some caution. You're not trying to add all these together. You're not trying to add that 6 to all of those over there. You're only adding them in the same spot that each one is in. Alright? Now with this problem has more positives and negatives. So you must pay attention to your signs. You've got to be very, very careful. Here we have a 5 being added to a -2. Don't say 5 and 2 make 7. You must ask, do I have more positives or do I have more negatives? The answer is I have 3 more positives. Adding this 3 to this 4. They're both positives. Positives plus positives make more positives. I add this 1 to this negative 6. This time I have more negatives. I have 5 more negatives. Alright? This negative 2 with this negative 7. Negatives plus negatives makes more negatives. And 0 being added to 6 is going to be 6. And lastly, negative 8 and negative 2. Negatives plus negatives makes more negatives, so we end up with negative 10. Alright, another example. Lots more. This time it has 4 columns and 2 rows. That's okay. We can still do the same thing. So we'll take this. Still addition. We say negative 9 and 5. Well, there's 4 more negatives than there are positives. We take this 4 and this 1. We add them together and get 5. We take this negative 2 and this 8. There are 6 more positives than that negative 2. And this negative 5 and that negative 7. Negatives plus negatives makes more negatives. We then have this 6 and this 9 add together to make 15. We have this 4 and this negative 8. There are 4 more negatives than that positive. And then we take this 2 and this negative 3. There's 1 more negative than there is positive there. And lastly, 3 plus 2 makes a 5. So even though there are more columns, we can still solve it the exact same way. Alright? And in this problem, this matrix C is made up of 2 rows and 3 columns. This one is made up of 2 rows and 2 columns. Therefore, we cannot do it. We will not be adding those together. That's as far as we can go in that problem. So it's really just adding and subtracting positive and negative numbers, but you've got to be very careful that you're actually adding the same location of the matrix C and putting your answer in there and watching your signs.